This is the applications of sequencing series from Oxford IBHLAA textbook. Let's start from number 1. So to solve the applications of sequencing series, first of all, we need to understand the context. Just try not to decide whether it is arithmetic or geometry or sequence or series before you read the full text, the full questions. So you need to understand the context first and write it down and decide. So let's start from number 1. In 2010, Sharp sold 220 televisions, and every 6 months 5 more, which means 10 more every year. So evaluate how many televisions the Sharp sold in 2017. So 2010, 220. Let's call this first term. 2011, 230. Second term. 240. This is the third term. So we need to know which term is in 2017. So my case, I try to understand with from the last digit when I see these years. So 1, 0 and 1, 1 and 2, 2 and 3, which means one more than the last digit of the year is the term number. So because now this is 2017, so this is U8. So I need to find what is the 8th term. So this is the arithmetic sequence because it increased the constant number, which is the common difference. So UN is first term is 220, 10 and minus 1. So U8 becomes 220 plus 70, which is 290. So we can say this shop sold 290 televisions in 2017. That should be the answer as a sentence. So number B. The total number of televisions sold between 2010 and 2017, which is S8. This is total number, which is the summation of these all numbers. So 8 over 2, and we already know what is the first term and the last term. 220 plus 290. So 4, 510. So 2040 televisions sold between 2010 and 2017. Number C. The selling price of the television was 600 euro in 2010 and fell by 20. So 580, 560, something like this. Okay, so since I call the number of television as a UN, so let me call this V1 and V2 and V3, which is Vn. So Vn, first term is 600 and the common difference is negative 20 and minus 1. So as described, the particular year, the number of television sold, which is UN 220 plus 10 and minus 1, was half of the selling price of each television. So this is 220 plus 10 and minus 1, 300 minus 10 and minus 1. So 20 and minus 1 becomes 80. So n is 5. So when n is 5, which is U5, the year is 2014. So in 2014, the number of television sold was half of the selling price of each television. Number 2, Jane Started working in 2000. On each successive year, she received the salary increase. Okay. So she starts 2000 and it increased. In 2011, 49,650 euro. So this is U12 because this is U1. 0, 1, 1, 12. So now, so this is the question. We don't know what was the first term. So let's say UN equals to U1 times R is 1.015 and n minus 1. So U12 is U1 times 101511 becomes 49,650. So U1 49,650 over. So from the calculator, 49650 divided by 0.15 to the power of 11. 42,149,54. Oh no, it asks the nearest euro, which is 50. So her starting salary was 42,150 euro in 2000. In 2000. And number 3, Carla traced her family tree back 4 generations. Carla's parents are first generation back, so Carla is here. So mother and father. So this is the first generation. And the second generation is mother, father, something like that, which is twice. And the third generation, twice, and blah, blah, blah. So now we know the first generation are 2 ancestors. First generation, we have 2 ancestors, which is mother and father. So let's call it UN 2 times 2 and minus 1. And how many ancestors are in family tree? And now we have 4 generations. So here ancestor, which is S4, because this is it is asking about the total number of ancestors. So the first term and 2 to the power of 4, 2 minus 1. So 15, 30. So we have total 30 ancestors. How many generations back she would have to trace to find more than 1 million ancestors? So 2 minus 1, 2 to the power of 2, n minus 1 should be more than 1 million. So 500,000 to n minus 1. So now we can make it log here with base 2. So n becomes log 2, 500,001. So again, from the calculator, 500,001. So 18.9 blah blah blah. So we need to go at least 19 generations back to have more than 1 million ancestors. So 19 generations. And number 4. Testing a recipe for a cake. Tries it out several times, adjusting amount of flour and sugar. So first recipe, she used 200. The first, let's say, flour and sugar. No? Okay, again, and anyway, 200 grams of flour increase the weight of flour by 20 grams. So second, 220, third 240, blah blah blah. So she will try 10 times. How many kilograms of flour will she needed? Oh, okay, so the sugar is not here. So let's call it UN. Just the starting, the first term was 200, and difference was 20 and minus 1. And we want to know the S10 because we need total number of flour, kilogram of flours. So this is arithmetic, and we have 10 terms. So 2U1, so this should be 400 plus 20 times 10 minus 1, which is 9. So 5 times 580, so 2900. So kilogram, so we need 2.9 kilogram. And okay, she has 1.5 kilogram of sugar available and knows that the amount of sugar needed is usually half of the amount of flour by weight. So let's say 100. After the first two trial, so this one is like half of the flour. So she decided to change the amount of sugar in each trial according to the geometric sequence. Number of trials would be allowed to carry out. Okay, so maybe because now this is times 1.1, so she needs to go for another 1.1. So 100 times 1.1 squared, blah blah blah. So let's call it Vn. So the first term was 100 and ratio 1.1 and minus 1. So again, she will try 10 times. So S10, 100, 1.1 to the power of 10 minus 1, 1.1 minus 1. So 100, 1.1 to the power of 10 minus 1 over 1.1 minus 1. So this is 1593.74 blah blah blah, which is larger than 1.5 kilogram because this is gram. So how reliable her model is, Georgia. So anyway, she cannot. What is the even the number of trials she would. Okay. So I did not do it properly. So this is asking how many times she can do that with 1.5 kilograms. So since the left side is gram, so here also should be gram. So this should be like this. What I use, the amount of what I use should be smaller or equal to what I have. Makes sense. So this one, 0.1. So 1500 times 0.1 over 100 plus 1 equals 1.1 to the power of n. So log 1.1, log 1.1. So n should be 1.1 9.6 blah blah blah. So she can use 9 times. And it is asking about the reliable, because it actually, this is a little bit stupid decision because it says the recipe should follow the half amount of the flour for the sugar. So for example, the tens, let's say tens as I mean U10, the amount of flour. Let's try nines because we can use only 9 times. So 9. So here 200 plus 160, which is 360. This one V9 100 times 1.1 to the power of 8, which is 214.35 blah 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 blah. So we can see this is not the half of the amount, so actually it's more. So this doesn't follow the proper recipe. So for me, I don't find this her method is very good to make this cake. Number 5. The first diagram shows a sequence of square. Okay. So this is now so if the side of the largest square have the length of 2 units, 2, second, third. So this is 2. And this is 1 and 1 and square root of 2. So let's say U1 is 2 and U2 no, not like this. I will call it L1. The first length is 2, second length is square root of 2, third length is this is half of square root of 2, and this is the square root of 2 times of square root of 2 over 2, which is 1. And L4 is 1 over square root of 2. Oh, okay. So yeah, we can tell there is some rule. So spiral was formed joining segment shown red lines in the second diagram. Okay, so use your answer part A. Find the length of the spiral shown. So how many times? So let's call this one U1. So now U1 we can see 2 plus 1, 2.5. So 2 times 1.5, which is 3. And U2 also square root of 2 times 1.5. U3 is 1.5. U4 is 1.5 over square root of 2. So U1, U2, here U3, and U4. So now we need to find S4, and we can tell there is the rule of it is making the next term by multiplying 1 over square root of 2. So the common ratio is 1 over square root of 2. So first term is a 3. 1 over square root of 2 to the power of 4 minus 1. 1 over square root of 2 minus 1. So 3, 2, 1 over 4 minus 1, and square root of 2, 1 minus square root of 2. So 4, negative 9, 1 minus square root of 2 over square root of 2. So 4, 1 minus square root of 2, negative 9, square root of 2. Just, I will write it like this. So this is the total length of the red lines. And Let's see what happened to the length of the spiral if you continue the process infinitely, which is as infinite. So u1 over 1 minus r. So 3 square root of 2, square root of 2 minus 1. And we can use this because this is this satisfies the condition for the infinism. Infinism should be like the ratio should be between -1 and 1. Number D, different spiral formed by shading the triangle shown the third diagram. Okay. Total area, shaded triangle, 1, 2, 3, 4, 5, 6, 7, 8. 2, 3, 4, 5, 6, 7, 8. So the first one, the area is 1 over 2 because this was 1 and 1. And the second one, square root of 2 over 2 times square root of 2 over 2 times 1 over 2. So 1 over 4. And if we find the next one, we may find the rule. The next one was 1, so this is half and half. So half, 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 1 over 8. So now we can tell. Let's call it V. So V1 was 1 over 2, V2 was 1 over 4, V3 was 1 over 8, blah, blah, blah. So this is the geometry sequence whose common ratio is 1 over 2. So S8, the first term is 1 over 2, and the common ratio also 1 over 2, to the power of 8 minus 1, and 1 over 2 minus 1. 1 over 2, negative 1 over 2, 216 minus 1. So like this. So 215 over 216. This is the area of the green zone. Determine the total area of spiral. Continue indefinitely. So again, this is S infinite. 1 over 2 minus 1 over 2. So the answer is 1. Let's go to the next one. Kyuhun takes out the loan of 1,500 to furnish his new student's apartment. The loan equal monthly installment. Interest is calculated monthly, charging 12% per annum. So per year is 12%. So this is not changing. The changing is just the interest amount of the like time, which means because this one, the bank, the interest rate is 12, and we apply this monthly, which is 1% per month, and 12% per year. So now we can say the per month is 1%. So loan is to be repaid in 2 years. So amount the Kyuhun has to pay each month if the first repayment is made 1 month after the money is borrowed, after interest is calculated. Okay, so 0th month, he had $1,500 as a loan. And this doesn't change the value yet because the time is still there. After 1 month, because already 1 month passes, so the value of this amount changing. So how much changing? 1%. So 1,500 times 1%. But he will repay. He will make repayment we don't know how much it is. Let's call it just X. So this is the outstanding of the first month, like after 1 month, after his repayment. So this is the amount of at this moment. And another month passes. Whenever the time passes, always the value of the money changing. So it is changing according to the interest rate. So now again, 1% should be changed. So now M1, 1,500 times 101 minus X. So this is how much I need to pay again. So all of this value, change its value with 1% interest. So this is how much I need to pay. And I pay another repayment. So this is the amount after I repay. So after I make repayment. So month 3, again, all of this money change the value again with 1%. So 1,500 times 1.01 part 3 cube x 101 squared x 101 and another repayment, something like this. So now we can tell we will go to another like 12 fourth month, 2 years. Then according to this pattern, we can say 1,500 101.24 minus x 101.23 minus x 101.22 blah 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 x, and should be repaid in 2 years. So I need to make the outstanding equal to 0 because I need to pay all. So this is what we need to make in 24th month. So okay. So now we can calculate it 1,500 because this has a different pattern. So I will leave it out. 1,500 times 101.24 equals. Let's move them all to the right side, and I will tie them with x. 123, 0122, blah blah blah, plus 1. So from here, just to make it simpler, I will see 1 as the first term, and this is the last term. So 1,500 times 101.24 equals x. The first term is 1, then go to the next term with like by multiplying 1.01 as the common ratio. So 1.01, and we have 24 term minus 1 over 1.01 minus 1. So x is 1,500 times 101.24 times 0.01 over 1.0124 minus 1. So let me calculate it, and let's see how much she should pay. 0.124 times 0.1 over 0.124 minus 1. So this is 70.61. So he need to pay $70.61 every month to be repaid in 2 years. Even evaluate how much to the nearest dollar, Gyuhun actually has to pay for furnishing the apartments. Because every month he paid this amount, and we will pay 24 times. So I think 70.61 times 24. This is how he should pay. So 61 times 24, $1,694.64. So he borrowed $1,500, but he need to pay $1,000, almost $700 because of the interest. And number 7. Architect designing something. Cinema should hold 570 seats. Front row should hold 30. Each consecutive row is to hold 6 seats more. So okay, U1 30, U2 36, U3 42, blah blah blah. So evaluate how many rows the cinema should hold. Okay, 30. Okay, so this is the S, and this is about the series. Should have 570, like this. So when we start from 30, no, because this is arithmetic sequence. So n over 2, 60 plus 6 and minus 1 should be 570. So n 30 plus 3 and minus 1, 570. 3n squared plus 27n minus 570. n squared 9n minus 190. So this is 10 and 9. So n plus 10, n minus 9 equals 0. So n should be 9. So we need 9 rows. The cinema, 9 rows of chairs to make 570 seats. For optimal viewing, the floor of the cinema needs to be stepped between each row is 15 centimeter high, 90. So like this, 50 centimeters, 95. Assuming that front row is 3 meters away from the screen, okay. And ceiling is 2.4 meter. Above the last step, determine the horizontal distance from the screen to the top row. From screen to the top row. Because we have 9 rows, so we have 95 times 9 plus 3 meters, which is 300 centimeters. So this is not about the sequence. So 1,155 centimeters, which is 11.55 meters. Maximum height of the ceiling, assuming it's not slant. This again, 15 times 9 plus 2.4. So 15 times 9, 240. So 375 centimeters, which is 3.75 meters. Earlier, Cindy each received 200 pounds from their parents with the condition they promised to invest it for at least 10 years. Alia invested her money in the account with Rapid Bank that offers 5% simple interest annually. So 5% simple interest. Simple interest is arithmetic sequence. Compound interest is geometry sequence, most probably. So account with Quick Bank offers 3.5%. Okay, so this has too much information. So A, B, C. each of them has 200 pounds. So Alia invested her money. So this has 200. Rapid Bank 5% simple interest. So 5% of 200. So she will get 5% of 200 10 times because she will leave it there for 10 years. And Bruna says it's better to invest in an account offer compound interest 3.5. So 200, 1.035. Another 10 years. So she will get the interest at 10 times. Cindy is not sure. So she invests 100 with Rapid Bank and 100 with Quick Bank. So Rapid Bank with this simple interest. So 5% of 100 times 10 plus 100, 1.035 to the power of 10. Evaluate how much each investment is worth after 10 years. So 200, 100. This is 300 euros. And this one, 200 times 1.035 to the power of 10. 282.12. And C, let's make it plus 150. So 291.06. So each of them has this result after 10 years. How much in each investment worth after 25 years? Okay, so this was the one, 25. Let's say, let's change only here 25 and 25 and calculate it again. So 200 plus 200 times 25. So now 450. And number B, 25, 472.65. And number C, plus 100 and 100. 461.32. So after 25. So determine after how many years the three investments yield approximately the same amount. Okay, so A, so this is more like a general expressions. So 200 plus 0.05 times 200 n equal to 200 times 1.035 to the power of n equals 100 plus 0.05 times 100 times n plus 100, 1.035 times n to the power of n. So all of this should be same, but I think it cannot be same, approximately the same amount. So in this case, we can draw the graph to compare them. So 200 plus 10n because becomes 200, 1.035 n, 100 plus 5n plus 100, 1.035 to the power of n. So we need to draw the graph, three of them. So let me try to sketch it from using the calculator. 200 times 5 to the power of x 200 plus 10x, 100 plus 5x plus 100 times 0.35 to the power of x. So now we don't know how much it will be, but it looks like 300, 400, something like that. So I will make the window of x from 0 to 25, let's say, and y from 200, since they started from 200 until 500. So I just try to sketch the graph. Of course, the beginning they intersect together and it's the same, and it looks almost what is that, on the way. At some moment, three of them goes very close to each other, and the B is going up further. So let me find the intersect, and it is around 20.5 years. So maybe between 20 to 21 years they have intersections. So after 22, 21 years, this may yield approximately same amount. Let's go to number 9. At the start of 2010, Karim has 5,000 to invest. Invest a part of the money in saving account offered 1.5% simple interest per year, 1,000 to his amount. Fixed it for 10 years in bonds. Oh, this also have too much information, so let's write it down. So 2010, he has, so part of the money in saving account, so we don't know how much he put, so let me put it just here, x, the saving account, x. And this is yield 0.15 per year, but we don't know how many years. Let me call it just n. And he put bond, he bought bond, x plus 1,000, fixed it for 10 years in bond offered 2.25 compound interest per year. Oh, so it doesn't say 10 years. And the rest of the money he invested in shares. So shares, 5,000 minus x minus 1,000, which is 4,000 minus 2x. But it doesn't say about the interest rate yet. After 1 year, the money invested in shares made a loss of 1%. Okay, so 2011, saving, bond, and share. This one 4,000 minus 2x times 0.99. The total amount of the money invested increased by 75. Okay, so here x plus 0.015x, n is 1 now. Bond is x plus 1,000 and 1,025. All of this becomes 5,075. So we can calculate it. So 1.015x and 1.025x plus 1,025, and just let me calculate it with solver. So solver, 1.015x plus 1.025x plus 1025 plus 4000 minus 2x times 0.99 becomes 5075. And when I calculate it, it says 1500. So he invested saving account 1500 and bond 2500 and share 1000. That's why altogether 5000. At the end of the first year, Carm decided to sell the shares at their current value and reinvest the money in the saving account. Okay. So this is what his the first 1500 calculation. So now he added another money. Let me just put it like this: 4000 minus 2x times 0.99 because this is the current value, and he will get another 1.5% simple interest rate. So this 1000. Let me write it as 1000. So 1000 times 0.99, which is 990. So 990, he added another 990, and he will get 0.015 interest 9 times. No, it starts 2010. So after 1 year was like at the end of 2010. So U1, this is so confusing. So this is at the end of 2010. So 2020 is U11. So this is after 11. So now we can say this is 10 and this is 11 and this is 11. So like this. So now I will calculate it: 1500 plus 1500 times 0.015 times 11, because the first saving amount will get the interest 11 times. And also this bond 2500 times 1.025 to the power of 11. So this and this and this he will get at the end of 2020. So now 990 times 10 plus 1500 times 11 plus 2500. So this is $6,166.22. Actually, he make 1,011. No, I mean almost 1,000, more than 1,000, which is good interest. Number C, evaluate how much more money he would have made if we had divided it up to 5,000 equally between the saving account and bond at the very start. So okay. So here I can we can make the calculation like 2,500 in the saving account plus 2,500. The interest rate was 1.5% and 11 times. The interest, he will get the interest 11 times plus bond 2,500 1.025 11. So let's see. This is 2,500 and if he made it from the beginning, like in this strategy, this plan, then he would get $6,193. So because it asks us to answer with interest at nearest dollars, so the answer is 6,160. So pharmaceutical company has developed a drug that fight the bacterial infection. So 37.5% of the original amount was still in the bloodstream every 6 hours. Okay. So maximum safe level of the drug in the bloodstream is 8 milligram. Okay. Consider the amount of drug in the bloodstream. The end of the day, 1. So first administration. So let's say 0 after 6, after 6, after 6, after 6. So this is first, third, second, first. So he take his pill here. Original amount, we don't know what is original amount. So this is the x. So after 6 hours, this will be changed, 37.5. So 0.375x. And he will get another, he will take another pill, another drug. So after 6 hours, this will be changed again, 37.5%. And this also will be remain only 37.5%, and he will take another one. So now 0.375 cube x, 0.375 square root of x, 0.375x, and he will take another one first. So altogether, this is the model at the end of the first day. So number B, this is the total amount. Oh, okay, so how do I call it? So A, the number A, the answer is 0.375 cube x plus 0.375 square root of x, 0.375x plus x. This is the number A. Number B, company advised that the drug should not be administered more than 10 days. Evaluate the maximum amount of that should be administered to ensure that amount of drug. 10 days means 40 times. So this is U1, U2, U3, U4. So we are dealing with U40. So from the pattern, U40 may have 0.375 39x plus 0.375 38x plus blah 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 plus x. This may be the concentration of this drug in the blood. So maximum amount that should be administered. So this should be not exceed 8 milligram per milliliter. No, I mean like this. So we need to calculate this one. So here x, and again when I will consider the first term as x, and the ratio, like to the left side, the ratio is 0.375. So 1 minus 0.375 to the power of 14, 1 minus 0.375 should be less than or equal to x, I mean 8. So when I calculate it, 1 minus 0.75 over 1 minus 0.375 to the power of 40. So 8 this is 5. So the maximum amount that should be administered is 5, because only that amount, I mean that amount is the maximum amount which can be the safe in 10th day. So 5 milligram per milliliter. 5 milligram. So number C. Drug start being effective when the amount of drug in the bloodstream is 7 milligram per milliliter. How many times? So let's see. So now we know this is a U40. So maybe UN is X. Now we know what is X5. 1 minus 0.375 to the power of N. 1 minus 0.375. This should be like from 7. So now 5, 7, 1 minus 0.375, 1 minus 0.375 to the power of N. So we need to do the log. We need to apply the log but with the base 0.375, which is smaller than 1. So when we apply the smaller than 1 log base, then we need to change this inequality sign because that function is decreasing function. So now log 0.375, log 0.375, but now we need to change it, the direction. So n 0.375, 1 minus 7 over 5 times 1 minus 0.375. This is 2, 1, 2. So the drug must be administered for the level of which. So 3 times, because twice still it is not effective. So from the 3rd time, it may be like if start to show the effect. So 3 times.